The main objective of this is to study and understand the typical embedded system, how it will be defined, and how the embedded system, which looks like in terms of block diagram, and how are the embedded systems have been classified. In these embedded systems, many types of embedded systems we have: general purpose, application specific integrated processors, instruction set processors, application specific integrated circuits, microprocessors, microcontrollers, and what are their differences. Oh, there are RISC processors, von Neumann, Harvard architectures. Based on these, the embedded systems and their classification has been done. This is what the objective of the module. We initially try to understand these topics, and after finishing these topics learning, what will be the outcome that we are going to achieve? We are able to explain, define the exact differences between the microprocessor, microcontroller, how an embedded system looks, how the embedded system is differ from the all other processors, and their classifications, how it has been done. Von Neumann architecture, Harvard architecture. Let us move on now to understand the definition of these embedded systems. An embedded system, it is defined basically as a combination of both software as well as the hardware, which does a specific task. The software which will be placed in the hardware of a computer to do the specific job, that software, it can be also called as a firmware. So where are these embedded systems we will be using? These embedded systems are used in consumer electronics, food processing industries, chemical plants, cement plants, biomedical equipments, telecommunication, and security. How the typical embedded system in its block diagram it will look like. This is an pictorial representation of an embedded system. It will have the system core, has the memory, it has the communication interface, input ports, output ports, and supporting documents. A typical embedded system it uh, it is defined as a embedded system which is dedicated computer based system to perform a application. The software which is embedded in the then where this software will be placed, the software will be placed in the read-only memory. The hardware of an embedded system consists of 6 different components: central processing unit, memory, input device, output device, application specific circuitry, communication interfaces. When you look at the main central processing unit, the core the central processing unit is the core of the embedded system that falls into any one of these following categories. The CPU can be made of different types of devices. The very first one, it can be the general purpose and domain specific processor based embedded system you may develop. Typically, when you look at this general purpose and domain specific processors, the microprocessor, which is available in the form of 8-bit, 16-bit, 32-bit, 64-bit examples, when we consider 8085, 8086. The manufacturers are plenty, but in order to have a gist who are the manufacturers of these ICs, they are from the Intel Central Processing Units. Designers are the Intel, AMD, ARM, Atmel, DEC, Fairchild Semiconductors, Hewlett Packard, IBM, National Semiconductors, etc. The embedded system CPU may also be designed with another type of processors, microcontrollers. They are available in the market in the form of 8-bit processors, 16-bit processor, 32-bit processors. The examples, if you look at here, MCS 51, MCS 96. The manufacturers are again many, almost they are from the same. They are Intel again, AMD, Atmel, DEC, Fairchild, etc. The embedded system CPU can also be designed with digital signal processors. Examples for these digital signal processors are C6000, TMS320, C6474, etc. These digital signal processors are also available in the form of 8-bit, 16-bit, 32-bit, or 64-bit. Again, the manufacturers for these digital signal processors are Texas, Freescale, Analog Device, NXP, Microchip, etc. The another type of CPU which is considered to be the part of embedded system is can also be the programmable logic devices, or they can be the application specific integrated circuits. The embedded system can also be the commercial off-shelf off-the-shelf components also. So now let us see the typical embedded system, general purpose processors and application specific integrated set processors. What the difference is if the embedded system is having the general purpose processor or the application specific instruction set processors. The the general purpose processor or GPP, it is also called as general computational, DOS, designed for performing general computational tasks. These GPPs are produced, general purpose processor, are produced in large volumes and targeting the general market. Due to high volume production, per unit cost for a chip is very low compared to the application specific integrated circuits or other specific ICs. A typical general purpose processor contains just the arithmetic logical unit and the control unit. You have another group of processors which are termed to be the application specific instruction set processors. These are the processors with architecture and instruction set optimized and to specific domain application requirements like network processing, automotive, telecom, media applications, digital signal processing, control applications, etc. These application specific integrated instruction set processors fill the architectural spectrum between general purpose processors and the application specific integrated circuits. The need for an application specific instruction processors arises when the traditional general purpose processor is unable to meet the increasing application needs. For example, some of the microcontrollers like AVR, USB AVR from Atmel, system on chips, digital, etc., are the examples of application specific instruction set processors. These application specific instruction processors incorporate a processor and on-chip peripherals demanded by the application requirement, program and data memory.